Okay, lesson 9.1, properties of radicals. We are going to do this lesson in two parts. So there will be two videos, so please look for part 1 and part 2, depending on what examples you need to look at. So what you're going to learn, to use properties of radicals to simplify expressions. So that's pretty much going to be part 1. Part 2 then will be simplifying expressions by rationalizing the denominator and performing the operations with radicals. So a radical expression is an expression that contains a radical. An expression involving a radical with index n is in simplest form when these three conditions are met. No radicand have perfect nth powers as factors other than 1. And a radicand is the number underneath the radical symbol. No radicands contain fractions, and no radicals appear in the denominator of a fraction. So you can use the properties below to simplify the radical expressions involving square roots. The first property is the product property of square roots. The square root of a product equals the product of the square roots of the factors. So if we have the square root of 9 times 5, we have the square root of 9 times the square root of 5. And it can simplify to 3 square root of 5. So as an example, we can see the square root of 108 can be broken up. So we're always going to be looking for the greatest perfect square factor. And if for whatever reason you can't find that, you can always find factors that will make a perfect square. So you could even do the prime factorization of 108, whichever seems to work easiest. But just always, always, always look for some perfect square factors. So the square root of 36 times the square root of 3 would simplify to 6 square root of 3. When you have variables, looking again for the greatest perfect square factor, we'll break up that x to the third power and make it x squared times x so that we can pull out an x out of the radical symbol. So we have 3x times the square root of x. So let's work on simplifying some of these. So I know that the square root of 24 is not a perfect square. Boy, it's just a little bit less than, 5 on the number line. However, I know that its constituents that it's made up of, it has the square root of 4 as a perfect square factor. So I would say that this is equal to the square root of 4 times 6. So then that could be written as the square root of 4 times the square root of 6, and then I can simplify the square root of 4 to be 2, and then leave the square root of 6 underneath the radical symbol, and I have it in the simplest form. For number 2, the whole thing will be negative. And I know that I could break up 80. Now, I could totally look at some simple things like, it's even, so I can divide by 2, or I could divide by 10, but 10 is not a perfect square. So I start looking for some perfect squares. So is it divisible by 4? Or by, and it is divisible by 4. And then it's 4 times 20, and then 20 is also divisible by 4. So you try to look for the largest perfect square, and in this case it's 16. So try all the perfect square factors, and I get 16 times 5. So I have a negative square root of 16 times the square root of 5. So negative 4 square root of 5 would be my simplest form. For 3, again, I want to kind of break this up. So I have the square root of 49 times x squared times x. So then I'll have the square root of 49, square root of x squared, and the square root of x. So 7x square root of x becomes my simplest form. For number 4, I'm going to have 25 times 3. And then again, if I take 1 away from n to the 5th power, I'll have n to the 4th power times n. So that'll give me, and in this case, remember, if you have an even exponent, you can divide that even exponent by 2. That tells you how many come out from underneath the radical symbol. So the 5 and n squared will come out, and what stays in is the 3 and the n. So 5n squared times the square root of 3n. Okay, the next core concept we'll talk about is the quotient property. So in this case, we know that the square root of 3/4 is equal to the square root of 3 over the square root of 4. So in our example, we start with where the denominator is a perfect square so that we could absolutely simplify that. So let's go ahead and simplify these. So this will be the square root of 23 over the square root of 9, which will equal the square root of 23 over 3. In this case, square root of 17 over square root of 100. Remember, the whole thing is negative. So square root of 17 over 10. Square root of 36 over square root of z squared, which equals 6 over z. Square root of 4x squared over square root of 64. That kind of looks like a 3. And so that's going to be 2x over 8. And hopefully you can see that the 2 and the 8 have a common factor of 2. So if I divide top and bottom by 2, I'll get x over 4 as my simplified factor.